Hello and welcome to our session on battery recycling. I'm Nick Holt. EVs are going to play a big part in the meeting sustainability targets, but they also create another big challenge down the line, dealing with the kind of less than eco-friendly batteries at their end of service life. So we're going to look at the recycling options and the recovery of valuable materials and the challenge of dealing with different chemistries and cell packaging. So with over 12 million tonnes estimated of lithium-ion batteries expected to retire between now and 2030, manufacturers need to be able to deal with this challenge. And it's going to be in epic proportions. I've been told it's very much a moment for recycling, as we'll find out in due course. So to get some insights into battery recycling processes and the challenges and opportunities ahead, I'm pleased to be joined by a very experienced panel for this sector. So to begin with, Sam Haig, who's Battery Recycling Business Manager for RS Bruce Materials and Machinery. Sam is a chartered chemical engineer specialising in waste and resource efficiency in the sector and has expertise in with batteries. He's responsible for the lithium-ion recycling operations for RS Bruce Metals, which specialises in the recovery of precious metal. Also, we have with us is Jason Muccioli. He's manager at e-mobility at Li-Cycle. Jason's product manager is a product manager with 11 years of experience in engineering and purchasing, and with strategy on focus on electric vehicles. And finally, we're joined by Jacqui Murray. Jacqui is Deputy Challenge Director of the Faraday Battery Challenge and the UK Research Innovation. Jacqui has a background in the steel industry, environmental regulation, and advanced materials innovation. And as the Deputy Director of the Faraday Battery Challenge, Jacqui helps lead the government investment in developing batteries that are cost-effective, high quality and durable. So quite a lot of responsibility, huge amount of experience here across the board, I know from having previous conversations with them. Just to sort of set a little bit of context here, I kind of want to I want to just get your view on. We'll go into some of the details a little bit further down, but I wanted just to get your views on what the scale of the challenge is. I did mention it a little bit at the beginning there, the sort of 12 million tonnes. So if I can start with you, Sam, on this one. Obviously, you're involved directly operating with the recycling side. What's your sense of the scale, where it is, where we're sitting now in the context of where we are now, the volumes, and where they're expected to be?
Yeah, thanks, Nick. I can speak mostly sort of from the UK perspective and a little bit from the European perspective, but really sort of what we're seeing in the UK at the moment is this sort of significant volume of sort of portable, what we call portable batteries, lithium from laptops and mobile phones, that kind of thing. But that's soon going to be superseded in the next few years by the automotive EV market, you know, and sort of smaller mobile power as well, you know, scooters and that kind of thing, which we're seeing smallish volumes coming through already. But you know, our own internal projections have suggested that by 2030, you could have, just in the UK, you could have 500,000 vehicles with some kind of battery in, some kind of lithium-ion battery in. Reaching end of life just in that year alone, you know, and if each battery is 300-400 kilos, you know, you're talking huge numbers, hundreds of thousands of tons of batteries to be recycled within the next 10 years.
And Jason, if I can just bring you into this, because obviously, you're based in the US?
Yes, correct.
So
yeah,
from that.
Oh, sorry. Yeah. So I was going to add that, yeah, the electric vehicle market's going to change drastically. So if you look back just a few years, there were only maybe 1 million, 2 million electric vehicle sales globally, with most of that in China. But when you look out to 2030, depending on what forecast you're looking at, globally, we expect tens of millions of electric vehicles being sold. So the scale is just enormous. And we're going to go from having almost no manufacturing capacity to support all those vehicles, so a huge amount of manufacturing capacity, and then as well as some of these vehicles start to hit end of life, and we'll have to recycle those batteries as well. So we're going to have a huge demand from the electric vehicle industry, and then a lot of other industries as well, like energy storage, e-mobility, and other areas as well. So all those industries are growing very dramatically at the same time. So, when you look out 5-10 years, the recycling industry is going to drastically change. And hopefully we're able to capture the majority of those batteries and recycle them and then get the raw materials back into the supply chains.
And Jacqui, your perspective, obviously you're again working around the UK base, but you're seeing obviously working with the ramp up of production as well. You're seeing that side of it and the sort of projections for what is necessary and what they're planning to do. So conversely, how do you see things in terms of the recycling side?
So I think all the things obviously Sam and Jason said are absolutely bang on. Faraday is really looking at how we manufacture in the UK. So what's also interesting to know as an ex-manufacturing engineer is you've already got 39 gigawatt hours per year of production confirmed in the UK, but by 2030 we're hoping to have it somewhere around 90 gigawatts. And actually what that means is you've got a load of scrap. And you've got to remember, as all manufacturing engineers will tell you, when you start something new, either a new factory or a new chemistry or a new design of product, you're going to get higher scrap, higher sort of yield losses. And actually that's got to go somewhere as well. And that's a real near-term demand or supply of these very high value materials out into the recycling industry potentially. So on all levels, it's going to be a challenge.
Just going back to the actual, this is the battery recycling process as well. So again, if I can bring in Sam, I mean, the question around here is there are two different methods of recycling batteries, I understand. So could you just discuss some of the pros and cons from your perspectives of those processes, and maybe a bit of the future direction as to where you see the sort of recycling processes going in terms of battery chemistry, configuration, etc., and where it will lead? Yeah,
absolutely. Thanks, Nick. Yeah. So you're right. There's kind of two main processes or two sort of routes that it can go down. Hydro, which is short for hydrometallurgy, and pyro, which is short for pyrometallurgy. And pyro is kind of the incumbent process, let's say, because there's a lot of installed capacity worldwide based in sort of previous metal recovery techniques for that have used this technique. And essentially it's a smelting process where the materials, whatever they are, but in this case batteries, are smelted down in a furnace, and then the target metals are essentially electro one or some other chemical treatment afterwards to get them out. And the competing technology is hydro targeted. I suppose the pro for pyro is, as I say, it's the incumbent technology. It's the dominant volume of sort of capability that's available at the moment. But on the flip side, it's often seen as a very energy intensive and perhaps less efficient way of recovering materials because it is a smelter. It's a very high temperature. So you are obviously having to put a lot of energy in for that. But another positive of it is that minimal pre-processing of the batteries is needed. You can pretty much put a battery straight into a pyro process. Whereas on the flip side, something like hydro, because it needs a chemical treatment sort of straight away, you do need some pre-processing in order to expose the materials within it, which is why you typically have an upfront kind of mechanical processing, which is where we're specializing, to get out what's called the black mass. And it's the black mass that contains the cathode powder, which is where you find the cobalt, the nickel, the manganese, and yes, the lithium as well. So that sort of adds a preliminary process step. So it's not quite as simple as just building a hydro process and going for it. But the sort of flip side benefit to the hydro is that you can do it at much lower temperatures. Even if you do these slightly elevated temperatures, it's much lower than a furnace. So there's less energy involved in the process. And because they're typically being developed specifically for lithium-ion battery chemistries, there's an argument that they're more efficient as well because they're bespoke for it. that's probably how I'd sum it up. I think one other thing is that with pyro, because of the high temperatures, you're running the risk of losing things like the lithium, which at the moment is not really recovered by anyone, but is going to be it's going to grow in importance as the volumes required grow, as the price increases, as we've seen happen this year already. And with hydro, you have a bit more opportunities to do that. That's what I'd say.
Nick, you're on mute.
Sorry, I know when we spoke last, your company was investing quite heavily in a new processing plant. So what's your sort of take on the processes and the sort of direction of travel?
Yeah.
Sorry, was that for me or Jason, Nick?
Sorry, that was for Jason. Sorry.
Oh, apologies.
No problem. So Sam did a great job summarizing the two technologies, and yeah, life cycle, we're investing in the latter hydrometallurgical process. We see the industry coming a lot more focused on what the environmental aspect of recycling is and the recovery rates. And for us, we see the solution being hydrometallurgical. It allows us to recover the lithium, as Sam mentioned, and pretty much everything that's within the battery. So we're able to get higher recovery rates at a much lower environmental cost. So it does take a lot of capital to build these facilities, but we see there being a return. In order to be able to recover the additional materials within the batteries and then do it in a process that emits a lot fewer emissions into the air and landfills. And so that's sort of the direction we see. We're creating our first hydrometallurgical facility in Rochester, New York, and then we'll do additional facilities throughout the world as we expand into other markets. So we plan to do a similar hydrometallurgical facility in Europe within the coming years, and then into other markets as well.
Thank you. And Jacqui, I mean, what's your take? I mean, obviously, what are you seeing in terms of the recycling processes and the pros and cons of them, and obviously the volumes that we are looking at?
So I don't think I can add much more than Jason and Sam on the actual practical side of that. And what I think from a government point of view is we don't think the answer. We think the answers are there. We think people know what they're going to do, but they need some help de-risking some of those investments. These are significant investments. So just to plug that on the 23rd of May, we're opening a £25 million competition for battery technology innovation, and that will include recycling technologies. And I think that's maybe the bit, trying to work out what works efficiently from an environmental and energy perspective, but also what works from cost effective, is going to be a challenge. And it's a challenge not only because those technologies some of them are established, some of them are relatively new or in a different application, but you've also got a feedstock coming through that's changing by the minute, depending on what the flavor of the month is in EV propulsion batteries. So there's a real complexity in this. And it's great to be part of a team sort of sitting relatively central in the UK that makes sure that we actually get people sort of coming forward and bring those ideas through faster, because from the volumes that you've described, we haven't got a lot of time to really get this up and running. I'm not so worried about capacity. I'm worried about whether or not by the timescales we need to be moving in, we're going to be having those efficiencies, those high efficiencies at scale that we want, particularly as we see pinches in prices for metals, for example, over the coming years.
Thanks, Jacqui. You raised some issues there, and I just wanted to bring it up. The sustainability of the actual recycling process. I mean, you mentioned at the beginning there, Sam, some of it's quite energy intensive, and something we've been seeing, we've been tracking on AMS for quite a while now, is that kind of sustainability sort of track, if you like, the transparency of that all the way through from a production point of view. Is that going to be a big factor going forward in respect of the recycling as well?
Well, I think it has to be, yeah, because there's no point doing the recycling if the way you recycle it is sort of more costly to the environment or to whatever than producing brand new stuff. And it's not saying that any of the recycling processes are anything like that. But you do have to keep an eye on that to make sure that you don't sort of approach that point. and I think just sort of a wider point for industry in general. Everyone's trying to transition to sort of cleaner ways of using energy, using cleaner energy. So I think there's got to be an eye on that. And I know from my previous experience working in completely different areas of recycling, something that's very important is being able to say, well, the carbon footprint, or however you measure it, of producing this material that's been recycled is lower than the carbon footprint of producing something, from that's been dug out of the ground. And the bigger differential you can make, the better, both for your product as a product, but also better for the planet. So I think, yes, it's got to be very important.
And Jason, so I was going to ask you your view on that.
Yeah, if I could add, I was just going to say it seems like electric vehicles have an extra level of scrutiny compared to vehicles in the past. And as Li-Cycle's worked with vehicle and battery manufacturers, not only do they want to know the cost, but they want to know the emissions of our process, like the LCA analysis of our process, and the energy from each of the steps of the process. So they're looking not just at the cost purely, but basically the whole process and what goes into it. And they want to get a better understanding of that. And they're taking that into account of, how they do their recycling and also how they do their vehicle manufacturing. So we've seen almost a huge industry change with electric vehicles compared to how everything's been done in the past. And that's good. I mean, it's starting to capture a lot more than just the pure upfront, cost of recycling or value of vehicle and what the entire picture looks like.
Thanks. And I just wanted to, Jacqui mentioned it there, and it was, again, another thought that came in when we're looking at, we've been certainly on the other side. In the last few days, we've been covering ramping up battery manufacturing. And we kind of know from our side, from the manufacturing side, that ramping up is not just making things faster. There is a big challenge there. Jacqui said just a bit earlier on that she didn't think there'd be a capacity issue, but maybe around the efficiencies. Talking to Sam and Jason, I know both companies have been working obviously in this sector, and as Jane and Jason mentioned there, they're ramping up. When you see those volumes, do you see the capacity to? And I know I appreciate this is you can't talk globally, but from your context, do you see the capacity being able of recycling capabilities being able to match the output of batteries, or the batteries that are going to come through into the recycling sector over the next sort of 5 to 10 years? Is there going to be a requirement for a larger scale investment on the side of recyclers to meet the demand?
I'll let you say something, Jacqui, if you want.
Yeah, I don't think I meant there wasn't a challenge. What I think I meant was the industry is really stepping up into the fray, from companies like RS Bruce and Li-Cycle, Li-Cycle globally, RS Bruce in the UK, but we're also seeing Veolia, Glencore, British Volt. We're seeing other companies. There's places like Iconicam in the UK. I think we're going to get to the point where people really not only want to be in that space, but want to be in the space the right way. And I think that's going to be a really exciting move. And it's that whole, what I think is going to drive it, though, isn't just people can see a market. They can see that market, and a huge market. But I think you're really starting to see the vehicle companies knowing they've got to do this right. You do not get away in this space with just not worrying about what the end of life is going to be for your product. And actually what that means is, if you're a car company, there's a big inherent cost. They say they put it behind the dash, and it's somewhere between probably $1,300 to $2,000 on every new vehicle being sold to deal with end of life liabilities. And I think that thinking is going to start to change the way engineers think about the types of batteries they put in, how they put them in, etc., because that's going to bring down that inherent vehicle cost, because consumers aren't content with saying, it doesn't matter what happens at the end, I'm just going to switch to an electric vehicle. And I think that's really critical. And some of the work I want to see happen over the next year in the UK is like looking at end of life recycling, looking at the environmental management of it, looking at the health and safety of it, and making it better. There's a huge challenge in it. But I think people are not just happy people can see that if you're going to be successful in it, you can't just do what's always been done and get away with it. In certain areas, you're going to have a really professional, really contained, very clearly defined recycling industry with battery passports or LCA data, or you can see how contractually you're going to want your recycling industry operating at a sort of tier 1, tier 2 level within the automotive industry. And it's going to be, that's a massive change. That's not just have we got enough recycling of batteries going on. It's can we behave in a way as an industry here that meets the needs of what the end products need and the planet needs. That's a great challenge, and I think you're going to see companies with ISO 14001 and other, maybe EMAS, etc., sort of accreditations alongside their LCA credentials, really being the ones that score those big contracts and close down or close the loop, as it were, with automotive companies.
That's interesting.
Just to add quickly to that, especially you just led it into it so nicely, Jacqui. Closing the loop's really important, because it's all very well saying we've got all this capability to recycle batteries, but then what do you do with the materials coming out of them? And at the moment we're kind of in a situation where things like cobalt and nickel, they've got a mass generic commercial market. But pretty soon we're going to be looking for homes for lithium and things like that, and large volumes of cobalt, nickel, manganese, everything else. And then you've got things like the rise of LFP, which is going to be a bit of a challenge. So the front end, what's currently the front end of the battery manufacturing sector, needs to be sort of thinking about, well, can I start getting materials from recycled batteries and putting them back in, and that needs to be done at scale as well. And
I think you're going to see as an ex-regulator. I think you're going to see the regulators and regulations globally start to close that or force that loop to close by setting targets on recycling content, and possibly even things like trading schemes. I'm sure Sam knows and Jason know their way around things like packaging recycling notes and the sort of trading type schemes around that. So I think if you're coming into this thinking, what you see is what you get, and it's going to stay like that in the future, you're going to get caught out pretty quickly. I think you're going to have to be looking at full sustainability, fully transparent, real data, transparency, and being able to operate in a very commercially recognized automotive and aerospace type industries. It's going to be a big challenge. It's an exciting one though for the planet. It's a real change.
Yeah, and just to add one last thing on closing the loop, a lot of the companies we're working with, it's becoming a very important issue for them. Not only do they want to track the materials like Jacqui was talking about, but to Sam's point, they're worried about their supply chain. So most of the raw materials that go into batteries come from just a few specific locations throughout the globe. And so by recycling, they're able to get a local source that should be close to their manufacturing too in the regions where they produce vehicles and batteries, which is a huge advantage for a lot of the vehicle and battery manufacturers. So closing the loop, it's just as important as recycling, and we're seeing that as one of the main takeaways from recycling is being able to close that loop and get those materials back into the batteries.
That's a really interesting thing. I mean, I would guess that to some extent the vehicle manufacturers are, because they know that of the challenge of getting in raw materials, and that's been exacerbated recently, that they are already, I would imagine that they were already kind of seriously considering using more recycled content as possible within it. I mean, I'm assuming there is a cost and supply issue maybe with that, but I mean, I don't know whether that's a case of whether you see that at the moment.
I think you don't want to confuse the car companies with the battery companies, the people that are making the cells, making the battery packs. They're slightly different, right? So you're going to see the battery companies really worried about that, and you're going to see the car companies putting pressure on them to know where they've got everything from, so that they can demonstrate that they're hitting either European targets or their own targets in terms of sustainability.
And just going back to the comment about the closed loop, I know from conversations, it was something I wanted to bring up in this conversation, was the idea that rather than being just an external supplier that's kind of almost out of that sort of kind of tier supply chain, that the view was that the recyclers must come in within that kind of tier supply chain. They must be part of the whole process and much more aligned. You're mentioning there about being more aligned. Is that do you see that happening? I mean, Jason mentioned about being about having recycling capability close to where the batteries are being made or where the cars are coming in, rather than just being wherever it's. And it could be it never seems to have been a consideration in the past, but now is that going to be more of a consideration going forward?
I don't know whether Jason wants to answer that or whether I should, but from my perspective, we're seeing globalization sort of shift over the last few years to looking much more closely at stable globalization, maybe, should we call it that, where you've got some really good localized supply chains that are more robust. And therefore you'll play tunes between cost and reliability of those supply chains, I suspect. I think therefore you've got to think slightly differently. So you're going to think about, if you're a battery company or a cell producer, you're going to know you need these raw materials in, so you'll be thinking about that supply chain. But actually, we've got 2.2 million cars going on the market in the UK, for example, every year, and therefore coming off the market every year as well. In time it will get to that level. In the shorter term, you'll have some warranty issues that might well give you some sort of increases in certain batteries needing to be dealt with sooner. But on the whole, you're going to see this gradual ramp up in end of life vehicle batteries, and they'll need collection, they'll need storage, they'll need assessing in terms of what they do. And there's a whole industry there that is currently around internal combustion engines that will need to transition as well. And I'm sure Sam's and Jason, they're in that area right now. You will have, though, these new gigafactories, right? You've got to see that if you Google the amount of new gigafactories coming online, they are going to need people that can take their scrap, and they will need close proximity services, because they're the ones that will want that material back round to them pretty quickly. And then you'll see actors in that field as well. You're looking at trading potentially in black mass or in, as Sam said, those materials to come back around. So you've got a really challenging supply chain to set up, and I think that's what's exciting. So you've seen big news splashes like Tesla buying into mining and VW buying into mining, and you're seeing Glencore buying into British Volt, for example. And I think the reason why we're doing that is as an industry is to really try and work out how some of this is going to play out. And I think you're going to start to see more and more of that going on, Nick, as we try and work out how this is going to work. I mean, it's huge change, right?
Yeah, I agree. And I think the industry is going to change quite a bit as it develops. To give an example, so today there's not much cell or battery manufacturing in the US, and most of it's in China. But an example, so for Li-Cycle, we have announced that we're doing a spoke or a mechanical shredding facility on site at the Ultium battery manufacturing plant. That's the joint venture between LG and GM. So we'll take their manufacturing scrap, shred it, and then we'll transport it to our hydrometallurgical facility in Rochester, New York, and go through the chemical-based process. So that'll all be very local in the US. And then hopefully there'll be precursor and other battery material manufacturing facilities in the US as well, so we can keep all those local, and even within the same region within the US and other areas throughout the globe as electric vehicles expand. So yeah, to summarize, I think we will start to see more and more localization, and a lot of these manufacturing facilities pop up right around certain areas where there is the vehicle and battery manufacturing.
And that's a good point. Those elements of your pre-cam and your cam, so cathode active material manufacturers and pre-cathode active material manufacturers, they're going to be a really important part of this supply chain too. And that's what I mean. There's areas that still there's gaps in, and there's also question marks in that we're looking to fill and understand as the transition happens across Europe and the US, for example. It's going to be an exciting time, Nick.
I mean, it's just interesting when we look at the operations around this, and as I mean, recycling's not a new process, and battery recycling isn't a new process, but we are seeing it develop and mature and grow. And it's interesting to see the levels of complexity, as you've mentioned there, the need for greater scrutiny, for greater collaboration and cooperation. One of the things I just wanted to come around to was some of the support mechanisms and approach to the dismantling of the batteries. We sort of been looking at them being built, and then sort of wondered about, whether about the service and repair side of it, or the way they can make the things like a sealed little ecosystem that they need to be able to function, but then be able to disassemble them, with reasonable sort of side. I mean, I know one of the things we discussed, Sam, with you was IDIS. This sort of, I don't think you said it didn't stretch all the way to full EVs at the moment, but it's basically an instruction manual for disassembling certain vehicles. I mean, I just want to bring you in your views on it, and maybe Jason as well and Jacqui, but just your views on that kind of mechanism being applied, and how much use it would be, or would it need expanding, or what's your view on that?
Yeah, I think just to sort of explain very briefly, because whenever I mention IDIS to people, they sort of get a lot of blank looks. But IDIS is the International Dismantling Information System, and it's a voluntary system that's been put together by a lot of the OEMs. And the way it works is that all vehicle recyclers have access to this system, which gives them pretty much a step-by-step instruction on how to do the preliminary pre-processing of the vehicle, which is called depollution. So to drain the oil, drain the fuel, blow the airbags, all the things that need to be done in order to make the vehicle safe for the onward treading process. And they are, you can search through that for any make of any model from any particular year group. As far as batteries are concerned, my understanding of what I've seen so far is that it tells you how to get the battery out, but nothing about what to do with the battery once it's out, in terms of how to do it safely and to dismantle it safely, and so on and so forth. So I do really think that the IDIS or something similar needs to be developed further, to be looking at battery dismantling. So explaining how to do a safe dismantling of the battery, how to take the lid off, what you're going to see when you get inside, where all the high voltage cables are and how they're marked out, everything like that. I think that would be really helpful for vehicle recyclers and battery recyclers, because I think one of the things that sort of needs to be touched upon again when we're talking about supply chains and how that's going to change is that the vehicle recycling supply chain is going to have to change, because all of a sudden vehicle recyclers who are used to petrol and diesel engine vehicles are going to start getting all these electric vehicles and hybrid vehicles, and they're going to have these batteries that they're not going to know what to do with. And there's sort of a real skills gap there, and knowledge gap of what to do with these batteries, how to treat them safely, even if as a vehicle recycler you don't actually want to recycle the battery. How do you get the battery out of the vehicle? What equipment do you need? How do you store it safely? Then what do you do with it? There's a big gap there that needs to be filled as well.
Thanks, Sam. And I think we're gonna touch upon vehicle architectures probably a bit towards the end, because I know there's a few comments about those. Just kind of moving on from that a little bit. When we're talking about finding out what's inside the battery, we talked about. I think Jacqui raised this with me as well. And I know Jason had some thoughts on this. So you'd mentioned it, obviously, about the value of the actual battery. Sometimes it's a bit of a mystery what you're going to get in there. So, I mean, the idea that to support the recycling of it, and Jacqui talked about sort of efficiencies. I'm assuming this might play into that, so that you're getting the best out of it, and certainly for the recyclers as well, was kind of simplifying battery identification. I know when I was talking to both Jason and Sam, they were firing sort of letters and things at me, and I was kind of thinking they were nodding to each other. So I thought, well, clearly there are some issues there. But it's interesting. But I mean, also, the more you know about what's inside the battery, the configuration, the chemistries, etc., makes it easier for you to know what to do or how to approach it or what the value of it might be. But I mean, I think, and Jacqui raised this, I think, when I spoke to her, it was, well, okay, what about the IP? Because we know that battery chemistry IP is pretty, at the moment, certainly, it's very kind of in development as it goes on, and people are very sort of close-lipped about it. So the argument is, if you just reveal all that information, you're essentially making that wide open. What's your view on sort of simplifying the process of, or where would you see the most useful points of this kind of battery chemistry identification moving forward to support recycling?
Who did you want to answer that one, Nick? I think you're on mute, actually. Sorry,
Jack. I was just going to ask Jason first, because I know he'd mentioned something about this a little bit earlier. Jason, do you know about the battery identification we were talking about? You and Jason and Sam were talking about that. And I'll bring back on that. But I mean, what you're saying about simplifying and being more clarity involved in that.
Yeah. So at least right now in the US, there's typically very little identification on the batteries. There might be a sticker that says nickel metal hydride or lithium ion, but there's no additional details beyond that. Maybe you'll get like the battery capacity, and that's about it. But when you look at lithium-ion batteries specifically, there's a very wide range in chemistries already today. So to name some of those acronyms, there's NMC, NCA, which both have high nickel, high cobalt in them. And then there's also chemistries like LFP or LMO, which don't have any nickel or cobalt at all. And what that means is there can be several different lithium-ion batteries, and the value within those batteries is drastically different. And this is already a challenge we deal with today, where we have electric vehicle aggregators or recyclers that come with us with batteries, and they're like, we have all these batteries, take them from us. And it's like, well, we have to know what chemistry they are to value them, to know if there is value in them or there isn't, and how, what processes need to be done to get those to us. And then going back to IDIS, there's also not much public knowledge in the US market on how to remove batteries, how to dismantle them. So that's another issue too today that we're dealing with as well. Nick, you're on.
Sorry, Jacqui, I wanted just to bring you back in, if that's okay. Sorry on that one. When we discussed this, I think you mentioned the fact that the challenge there was what happens with the IP. There is where do we kind of draw the line? I know you're involved in kind of around standards, etc. So what your views on that were?
So I think if you look at it from a government perspective, I know governments around the world are wrestling with this. There's a real sorry, excuse the noise in the background. I think kids are coming out of school right now around me, and everyone's got dogs and everything. But governments are struggling with this, right? They're trying to think about, how do we make sure batteries coming out of vehicles are safe, because these are high voltage live systems, right? It's not like your light switch where you can switch it off, or a product where you can switch it off and it's fine. As soon as you take that battery out of its management system, out of that vehicle, you've got a system that's live and dangerous, right? So buying vehicle modules on eBay is something that we're thinking about now, because these things are dangerous. How do we get batteries out of vehicles that have had a crash? All those things are being thought about, right? In terms of the IP, when you have that massive rush in terms of innovation, companies are naturally really worried about giving away their golden goose to somebody like Sam, who's like, yeah, no, it's great. Tell me what's in your secret sauce of your black mass, and we'll then quite happily tell everybody, but also recycle it. And the answer is that one, RS Bruce aren't going to behave like that. Two, they probably don't need to know the real intricacies of what you're doing. chemistry wise. They're more but they do need to know the bits that are relevant to the recycling. And what you're starting to see is things like battery passports. You'll start to get agreements between companies where actually we can bring that circularity round. I saw this week, we've seen companies like Circular get working alongside Audi and BMW and Umicore and Fraunhofer's and BASF and a load of others get sponsored to really pull through and get the data collated into a battery passport. And it means that you're going to start to see much more nuance, much more intelligence coming forward, so that actually when you try and you get the batteries back in Li-Cycle or RS Bruce, you're going to have a better idea from scanning something on the battery what's actually in it and what you need to know for your process at that point, rather than, we just have to put a materials data sheet requirement out there where every battery materials company has to tell you what's in every battery. And so you're starting to come away from that sort of quite basic, simplistic way of looking at the system to providing mechanisms where things are much more nuanced, much more intelligent, as we are around internal combustion engines, right? As we are around materials that go into them and advanced materials that go into them. So there's challenges around that, but you're starting to see it happen, right? And I think that, again, it gives you real opportunities as companies to establish yourself in that new market, in that new way of working for electric vehicles. That as right? It's not a case of we want electric vehicles to come forward that damage the environment or damage people or anything else. So you're starting to see that happen now.
And Sam, if I can bring in you on that, I think when we spoke, obviously the battery identification side of it was when we were talking with Jason was an issue. I think we touched upon the idea of a battery passport. What's your kind of views on that?
Yeah, well, I think just to touch upon what Jacqui was saying before, we don't need to know down to the third decimal point percentage of what's in the chemistry of the cathode. We don't need to know the specific structure that's all been put in. Once you get to our side, it is mostly a sort of a metals business. So we just need to know on sort of bulk level what's approximately the metals in it, to the nearest few percent or something. But putting that aside, I think it would be really interesting to have that kind of thing. And we haven't really talked much about Second Life, which is you could spend another 45 minutes talking about that. But I think it could be really interesting for that as well, if you could get some kind of sort of data log of what life the battery's been through. It says that it's been charged and discharged this many times, and it's this is the maximum temperature it's seen for this long, and so on and so forth. That could be really helpful for sort of quickly grading batteries. Sort of a pre-triage almost. I think you could use it for something like that, and obviously if you've got information about what's within it as well, that's even more helpful. Yeah.
Thanks, Sam. We've just got a couple, like you say, we could do another 45 minutes on Second Life, and we have got. I know we did discuss Second Life around it. I think I just wanted to focus mainly on the kind of the recycling bit while we're here. But the last sort of kind of question or discussion point would be around vehicle architectures, because the way that the vehicles, if we look at the way that the battery cells have been packaged within the vehicle in separate boxes, in the way they're engineering it, we're hearing now that car makers they're evolving that reasonably rapidly, actually, given it's a fairly structural part of the vehicle. I think they're clearly trying to simplify the engineering of the cars as well. We're hearing about sort of cell to car sort of battery systems. I think when I mentioned it briefly to Jason, Sam, Jacqui, you all had opinions on the fact that this adds this development on that side, which helps the car makers actually could really complicate things again, moves the goalposts again for the recycling processes. Sam, do you mind if I bring you back in on this again on this one? Because I know you had a few views on this. We've only got a couple of minutes, but
yeah, I was going to say, do you really want me to? It's it really is a sort of seesaw. The things that make manufacturing the cars easier and so on and so forth, very often end up making more difficult at end of life. So it really sort of has to be taken into consideration when we're putting these kinds of designs together. And vehicle manufacturers have a responsibility, in Europe at least, they have a legal responsibility, but they also have an ethical responsibility. To, if they're putting loads of stuff into cars, then they need to take some responsibility for how it's dealt with at end of life. And I'll leave it there because I know we're short on time.
Well, I'll quickly get a response from each of you. So, Jason, can I ask you what your view is? And I've got a couple more minutes, been allowed a couple more minutes. So if you want to just feed into that.
Yeah, so it's challenging. The technologies for electric vehicles are already changing quite a bit. At Li-Cycle, we've tried to create a versatile process so we can accept different types of feed. So we can accept cells, modules, and even full electric vehicle packs at some of our shredding facilities today. So we could shred a whole pack if we needed to. So if we get like something damaged and we don't want to disassemble it, just put it through the shredders. That being said, that doesn't always make that's not always the most economical way to dismantle and recycle batteries. We still may dismantle them and then shred the modules or the cells, and that might be a lot more economical of a process to do. But yeah, looking forward, some of the vehicles that may be cell to vehicle, we may have to have more elaborate, larger shredders to be able to process those if they're not easily disassembled, or go through some other process to basically separate out the battery from the vehicle. So that's something that we're watching, and it'll be interesting to see where the industry goes.
Thanks, Jason. And just a quick word from you, Jacqui, on that, if you don't mind. Obviously, with Faraday, looking at developments and where you're guiding people.
Yeah, I mean, what I love about Faraday is we sit in a central position and try and own the problem. So this isn't something that's new actually to electric vehicles, right? What you have in a vehicle is a really complex product that has a huge amount of requirements on it, whether they're regulatory requirements like safety or environment, or could be LCA, for example, but also meeting what your consumer wants, right? So lightweighting vehicles has been a requirement for a long time. It reduces your emissions if it's internal combustion engine, and actually it makes everything more efficient, but cars haven't lightweighted, and the reason for that is because we also require them to be safe. And so some of the crash structures within vehicles have also kept them relatively heavy as we've lightweighted the materials. It's coming from the steel industry, I can tell you. That's certainly something we saw them have been seeing them doing over the last 20 years, right? But cars haven't got that much lighter, even when they're internal combustion engines. So there's always these competing odds. What I think we need, and we're trying to do a lot more of, is sort of oriented collaboration, teams, people like Sam and Jason working alongside and exploring with car companies, with engineering designers, with component manufacturers, battery pack manufacturers, and cell design, what really works at every level, every stage. It's a real proper systems thinking sort of challenge that we have here in 2020.
Thanks, Jacqui. Well, I'm going to bring the session to a close now. We have run over a little bit, but it's been fascinating talking to all three of you. Thanks very much for your input. Really good. It's a completely new area for me, the recycling side. So it's fantastic to see it, and it ties in so well to where we're seeing the automotive industry full stop going. It's a really important part. So again, thanks very much for your time. Much appreciated. We'll continue after a short break. We've got looking at development and application of digital tools in an upcoming session covering AI, connectivity and data management. And stay tuned for a detailed look at how production planning is developing with new digital tools and how it's working in practice. So thanks very much for joining us, and goodbye for now.